Hey YouTube, Bill here again in Bill's workshop. Started doing some parts for my CNC conversion. I still got the motors on here for the X and the Y, and that is only for the stock screws. I took the plans from Haas machine, and he's got a good DVD on this stuff on the dimensions and how to cut the parts out for different scenarios. You can use square or you can use round standoffs for the motor mounts. But anyways, to make a long story short, I'm using the stock screws on here now. I've already ordered and have received the new ball screws and ball nuts, and now I'm making the mounts for those ball nuts. So this here is for the Z, and I started digging into this a little bit, and then I realized that the way I had this thing set up and clamped in here, this clamp was over here on this side, and there was no way that this head was going to clear that clamp and also the bolt back there. So I moved everything around, tried my best not to disturb this plate. I kept this clamp in place, which helped it, or kept it from moving. So anyways, this is how the part's coming out so far. As you can see, it's really a clean cut. The plans call for the top up here to be 2250, which is 2 inches, 250 thousandths. And it is currently measuring about 2 inches, 248 thousandths. But that's okay from what it's going to be used for. It doesn't have to be that critical. This part here is supposed to be 1 inch, 250 thousandths. And it is measuring at 1 inch, 254 thousandths roughly. I got this bolt in the way of my caliper, so it's kind of hard to get a real good measurement where you can see it on camera. But anyways, I'm pretty pleased with the way it's coming out. The whole pattern is good. What I did is I drew this part up with the design from, again, Haas's DVD, and I mocked this up in Fusion 360, you know, with all the angles, the measurements, the diameter of the holes. I have a boring head that I did this with, but I would have done this through the CNC and using a end mill instead of boring it. But the problem is I have no motor on my Z, so everything is done by hand. So I didn't want to do no pocketing for this hole with an end mill. Even with the table moving on the Y and the X axis, I probably could have done that, but I didn't feel very safe about that. Just because when you're doing an operation like this, especially if you're spiraling down, you want to make sure that, you know, all motors are functioning properly. So I just went ahead and used my boring head to do that, and got it to within specifications. So yeah, I'm going to do one more cut with this real quick just to show you it and let you see how it sounds. My Y is still making a sound when it's pushing the table away, and I think that's because the center hole on here is not big enough. That goes through here that the lead screw comes out on. So I believe that the lead screw might have a little bit of a wobble or warp in it, and if it does, that's going to cause it to hit the walls inside. Even though there's a bearing in there, I'm using the stock bearings. But those are going to be replaced too once I get these parts machined. Then I'll put regular AC bearings in here and in here. And of course I'll be replacing this all together with AC bearings, and I've got the motor mount for this. It's set up right there. So I'm really ready to go. I just got to wait for the bearings to come in, and they're supposed to come in by tomorrow. So anyways, let me go ahead and pause this so I can get this machine back into a depth of cut and let you see it machining. We'll only go maybe twice around, I guess, just so that you can see it. There's a lot of videos out there on people machining these parts, so you know, it's not like it's anything thrilling to watch, but a lot of people like to see how accurate the machine can be even with just stock screws in here that came with the mill. Alright, so I'll be right back in a second. Alright, I got the bit down in there. It's not really touching right now, but I'm going to start it up and then I'm going to fine feed it on here. Whenever you're doing manual machining for your Z, you want to always make sure that your gibs for the Z are locked, because that will keep your tolerances tighter and it will make the cut more accurate than if you didn't. Of course, when the Z is CNC'd as well, then there will be no need for those. The only purpose that they'll serve is just to keep the gibs somewhat tight, so that way you get a little bit better accuracy. Okay, so anyhow, let's go ahead and get this show on the road and show you the first 2 passes of cuts. The first cut I'm going to take is probably about maybe 10 or 20 thousandths of a cut, and in the next pass I make, I'll probably do the same thing, another 10 to 20 thousandths. Hope I plugged it in. There we go. Alright, let's try this again. Okay, unlock the quill and fine feed it until it starts cutting. I'm going to zero my draw. Now we'll do 15. Lock your quill in place. And then we're going to hit start up here on Mach. Hear that sound? That's from the Y pushing the table away. Okay, I paused Mach, unlocked my quill, take her down another 15 thousandths, 20/30 up the cut, lock the quill, start up Mach again. There you go. As you can see, the corners still look pretty sharp on here. And it's very even on the sides of the walls. So I'm pretty happy with the way that this is turning out with the stock screws. I can imagine how accurate it's going to be when I get the ball screws inside there all taken care of. I think I'm going to be pretty happy with this setup for quite a time to go. Basically want to make signs with it, use it almost in the sense of like you would use a CNC router setup, but I like the option of being able to do metalwork as well. So thanks for watching, and tune in again when I get everything all upgraded. I will post another video and show you how that works with the ball screws. Until then, take care, YouTube.